Alrighty, well, good afternoon. Welcome to the last session that you're going to attend at Build 2017. You made it, so congratulations to you. So who remembers everything that they've heard in the last 3 days? Yeah, so we're going to spend another hour filling you full of a bunch of stuff. Hopefully you can remember some of it.
You should remember the first thing, the last thing, though, right?
Yeah, exactly. All the stuff in the middle is just mush. It's not important. So I'm Matt Usher, and this is Josh, and we're PMs at Microsoft. We work in a couple of the data services. So we're going to spend a little bit of time today talking about kind of how we architect some of the solutions that we have at Microsoft. What do we do with all of these tools? So give you kind of a case study of what it's like to build one of these services, one of these solutions on a lot of these Azure services you've been hearing about, and kind of how you put it together. And we're going to dive deeply into kind of two of them, specifically Azure SQL Data Warehouse and the Azure Analysis Services. So we'll talk about those kind of services, how you would connect them, and some of the gotchas, so you can kind of walk out of here with a little familiarity. So we'll think about when we think about kind of Xbox, you think about kind of the scale problem that Xbox has. So Xbox is a massive console ecosystem. If you think about, sorry Josh, I'm walking behind you. If you think about all of the console games, obviously, that are out there, you think about kind of Xbox now as part of the Windows 10 desktop, where you can actually go in and play games off the Xbox store directly on your Windows PC, as well as just mobile devices, right? So there's a massive ecosystem around Xbox. And you can think, okay, they have a big data problem. Right? How do they deal with that? How do they go get insight out of that data? How do they manage that data? How do they analyze that data? How do they report on that data? So what do they do? Because that's a big data problem that you could really, truly understand. So I'll give you some stats around Xbox just a little bit. If you think about something like Minecraft, right? Minecraft is a massively popular game. Sold 25 million copies and counting on Windows and Mac alone. If you count all the other devices, it's 120 million plus games sold. So you can imagine the telemetry coming out of something like Minecraft. How many pieces of information are coming out? Where users are in the games? Where do they get stuck? What kinds of places are they building, or what kind of things are they building within the game? Those kinds of things. If you think about something like Forza, Forza is a $1 billion property for Microsoft. It's got over 14 million registered users. It's one of the fastest, or one of the largest kind of gaming titles there is in the gaming industry. And you think of something like Halo. Halo's a massive, massive endeavor. So with all of the launches of Halo, at something like 65 million copies sold worldwide. It's become a little over a $3.5 billion business, just in Halo itself. And you think, okay, well, imagine all of the telemetry coming out of that, right? With something like online shooters, something like a Halo game, where people are playing, where they're hiding, what tools they're using, what guns they find, all of those kinds of different, pieces of the game are being ingested so that we can make the games better. We can understand what people are doing, and we can optimize kind of the experience through the games. And these are just some of the titles. You think about things like the Xbox console itself. So if you're looking at your Xbox One and you're sitting in your house and you've got it up on your TV and you think, how did they decide on things like menu placements? Just simple things like that. What if we introduce a new feature? Maybe you're aware of it, maybe you're not. So you have to think about how do you kind of build a game from that perspective, or a console from that perspective, and allow you as an end user of that game to get the best experience you can possible. So truly being kind of customer obsessed. So thinking about how does a customer utilize the game? How do they utilize the surface? How can we better improve that? And so you think about all of the data and telemetry coming out of all of these pieces of games, consoles, desktop apps, mobile apps, and being able to take all of that data, aggregate it, and make sense of it. So you can think of things when we hear Scott and Satya on stage talking about data scale at Microsoft. We now talk about things in exabytes, which is a really large amount of data. And so if you start thinking, well, how do I find what my users are doing in that? So really kind of building a case study around how does Xbox go and Microsoft Game Studios go and build all of this insight into what their users are doing. So that's what we're going to talk about. So we're going to start with kind of the basic architecture. So this is kind of how the system goes together. On the very left-hand side, I'll kind of walk you through this. There's a set of kind of inputs, right? All the things that you would expect. So things like game telemetry, for example, or ordering information. So things like sales and inventory systems. So really kind of all that insight into what's going on. That data's landed in a couple of internal systems. One of them, which is basically the genesis of things like Azure Data Lake. Internally, we call it Cosmos. So you've heard a lot about Cosmos and the Azure Data Lake service. And so it ingests some of that telemetry data. Ultimately, it lands in HD Insight. This is all moving to the Data Lake service now. We use event hubs for obviously any kind of interactive information, so things streaming into the system. And once it's landed there, we use that as a giant data lake. So all that data is landed. Now at Microsoft, we have a set of analysts, we have program managers who work on the games and the consoles that are looking at that telemetry, but they don't go looking through all of it. Right? Nobody really cares about individual clicks. Now data scientists, our data scientist team, will go through and do all kinds of data scientists algorithms to try to figure out kind of predictively where people are going to get stuck or what levels are harder and where they maybe want to incent people, those kinds of things. So they'll look at the raw data. But when we want to look at things at kind of like aggregate scale, we start to build the solution out. So we use something like Hive inside of HD Insight, and we pre-process all of this data. So we get it into kind of a somewhat clean state, and we use that to pull it into further downstream systems. In this case, the way it works is that Hive data lands in blob storage, and then we use an ADF pipeline to pick it up off blob storage, and we use a technology inside of SQL called Polybase, and I'll explain all of this in a minute. That data is then ingested into SQL Data Warehouse. It's then crunched and aggregated in scale for what either our standard reporting looks like, things like average daily users, something you would expect like that, or monthly revenue, or usage of particular components of a game, for example. And then it's scaled. We use something like Azure Analysis Services to scale all that data reporting. And then it's ultimately consumed in things like, honestly, Excel, Power BI, SQL Server reporting services, a bunch of other tools. And so this is kind of how the pipeline works. And so when you think about kind of the data moving through the system, there's a bunch of moving parts. And so when we put this case study together, what we wanted to illustrate to you is how you could assemble all of this to solve your problems. Right? It's great that we're showing you how Xbox does this, and we can show you how we do it at scale. But this isn't an uncommon solution. We see this very often at a lot of customers. When we talk to customers, they'll say, hey, I land all of my data from my mining equipment. I've got IoT devices now on everything in my mines, and so I need to land that data. Or I happen to be a retailer, and so I'm ingesting data from things like my point-of-sale devices, but I'm also now getting partnership data from, say, my vendors. So maybe the company who brings in the bread is also giving me some data. Where do I land that? How do I ingest that and start to make sense of it? And they'll also pull external data, so things like industry data. So you think of something like Nielsen, the TV company, right? They go do ratings, and so there's a lot of companies who ingest that as part of their products and product offerings to get insight into what consumer behavior is and be able to take that data in. So using all of the data and building these pipelines down through the system really gives you the ability to take all of this data, move it through kind of all of these different services depending on their use, and ultimately come out with a result, which is really what your end goal is. How do I make my business better? How do I make my customer happier? How do I become more efficient in what I do? Because what I've seen for a long time is that nobody really cares about this slide except for the architects and the engineers. The people running the business never care about a slide like this. Nobody ever walks in your office and says, hey, tell me how many cores it's going to take to know how many shirts we sold this week. Never happens. What your boss wants to know is, hey, tell me what happened in the Midwest with our inventory. Tell me what happened when our competitor put 10% sale, and what did that do to our West Coast sales? So those are the kinds of questions you're being asked at a macro level. So having these systems in place enables you to get the data very quickly, be able to do it at scale, and be able to get insight out of it. So when we think about kind of data itself, there it goes. So we think about kind of data as a key strategic asset. Now, we're talking about relational assets. So specifically here, we're going to talk about SQL Data Warehouse, which is a SQL-based relational database. We're going to talk about analysis service, which is, again, SQL-based. When we think about that, we think about kind of why do we care? Right? There's all this press and all this to-do about Hadoop and all these other services. Why wouldn't I just run all of this in HDFS, run Spark SQL over the top of it, and be happy? Right? Doesn't that work? What you realize very quickly is that most customers don't have their data in that way. Most customers aren't even thinking of moving that way. In fact, what's actually happening are these relational assets are exploding very, very fast. And so you see things like the Azure SQL Data Warehouse service growing very, very rapidly. And the reason is kind of twofold. One, because they're systems that people are familiar with. So most people have some kind of SQL skills. They're very familiar with those kinds of assets, or they have those in their environment. So their employees have those skills. They're comfortable with kind of the language and the surface and being effective and efficient. And so enabling those customers to be able to take the skills they have and move to a big data solution means that we don't have to retrain you. And so being able to teach folks how to use the systems that they already know at just a different scale is really easy. And I'll show you in a bit on how we do that. When you talk about also the Hadoop ecosystem, it's very mature. We talk about databases having been in industry for many years. SQL Server's, what, Josh, 25, 30 years old at this point? So it's got a lot of maturity behind it. Things like security models are just baked into the system because they've been there forever. You watch the Hadoop ecosystem, for example, starting to think about, oh, how do I run single sign-on into my Hadoop infrastructure? Something very simple and basic you would just assume is there isn't. And so there's this massive effort to be able to take all of those assets and continue to grow. Now, when you think about a company today, it's strategically important to be able to manage your data assets. And what's critical is that once you understand what your company has from a data perspective and what uniqueness that offers, then all of a sudden you can start to expand your business. And you can see this in a lot of different industries, right? You look at, there's this kind of classic case study of Anheuser-Busch here in the United States, make Budweiser beer. And what they used to do is they would go out and have their delivery guys go and show up at a store. And they would say, hey, here's how much beer I put into this store particularly. So I put in 10 cases of beer, a Bud, I put 5 cases of Bud Light. So that's how much we sold. They were really smart. What they did at the same time was they said, how many cases of Coors are missing? How many cases of Coors Light are missing or are in the store? And they started tracking everybody else's data. And what they did was they didn't build up just a knowledge base of what they have. They built up a knowledge base of what all their competitors have. And you can be sure that they use that to get insight as to how their competitors' business is doing. Where is it when Coors puts a sale on? Do they sell a lot of beer? Where is it when they put a sale on? Doesn't seem to matter because nobody drinks Coors in that region, right? So you have these kind of perspectives on data, and you can use that to your kind of competitive advantage. And so when you think about kind of all this new data that's being exhausted, right, it's a great term I've heard, that it's coming from everything, right? Who in the room has a Fitbit? Who in the room has a cell phone, right? Who in the room has a tablet? If you think about your car coming in, I have a new car. The thing emits data all over the place, right? The thing's constantly sending me alerts like, hey, you know what? Your tire pressure in this one went down one pound, right? Like you gotta put some air in it. Like everything now is emitting telemetry. We talk about internet-connected toasters. It used to be a running joke that at some point we're gonna connect toasters. Happened to be in Home Depot the other day and I walked by and there's this TV with this giant screen that you can basically do everything you need right on the TV. Everything now is emitting data. So it's an opportunity to take all that data and actually drive it inside into your business. Okay, so now we're going to flip a little bit. So we're going to start talking about these services. So specifically, I work in the Azure SQL Data Warehouse service. So this is my background, and I'll kind of drive into what this is. So who knows what the SQL DW service is? Everybody? Great. Anybody not know? It's okay to be honest. Okay, now I have one more question. Does everybody know the difference between what SMP is and MPP? Awesome, great. I love crowds like this. You guys are great. So I actually get to teach you something. So SQL Data Warehouse is a SQL server-based relational data warehouse. It's built for scale-out large database problems. So you can imagine, I've taken all that data that I get from Xbox, I shoved it into something like SQL DW, and now I want to run queries and get insight out of this, but it has to be fast. So it's built for these large latency queries. So imagine you're running a query that says, show me all the people who ran into this location in a game and got stuck. Well, that could be over hundreds of millions, billions, trillions of rows of data that you want to analyze and crunch very fast. So this is a scale-out relational data warehouse with multi-node running all as a single SQL server surface. It really gives you kind of all kinds of new ways to do things that you couldn't do before. It takes all of this data using all the tools you're familiar with, so SQL server-based. We'll show you SSMS working, SSDT, all those tools and structures you're familiar with working on. Excuse me. It allows you to take advantage of this scale out without really having to know a lot about how the scale out technology is working. We do all that heavy lifting for you. Because it's a scale out solution, what it does in the cloud is we've taken this concept of taking the compute component and the data and separating those. And so your data lives in somewhat cheap commodity storage. There's kind of this race to who's going to give you the most storage for free at this point. We'll see who wins, but essentially the big cloud providers are giving away storage at really, really cheap rates. So storage is cheap. Getting your data there and kind of just landing it is cheap. Being able to compute over it is expensive. And so we allow you to control how much compute you want and being able to scale very quickly. So there are parts of your day when you're looking at data coming in, you need a lot of compute power. Maybe that's in the morning if you're doing single day loads. Maybe that's every 10 minutes you're loading up. So you can scale the compute, do your loads and aggregations, and then scale right back down when you don't need the compute power. So you can optimize your spend. It's a service based on this concept of secure first. So we have all kinds of layers of security built in the system. We have things like single sign-on through Azure Active Directory. If your Active Directory on-premise is federated to the cloud, similar to how we do at Microsoft, I just sit down on my desktop and I sign in all the way to the cloud to my cloud service, and I'm single signed on. I don't have to remember usernames and passwords. Things like transparent data encryption, which is encryption on disk. So as your data is written down to disk, it's encrypted. And as it's read from disk, it's decrypted so that it can be used by the service. So your data is always stored in a format that's secure. So we really do things like that. We have integrated threat detection. So you can imagine Microsoft runs millions of databases running in the cloud. We've been able to build systems that go through and look for data anomalies in kind of things like security threats. So currently there's a giant DDoS going across with all kinds of break-ins happening into companies today. It's actually happening live as we're speaking. It's been kind of reported in the news all day. When we think about kind of how these systems work, we have things like what we call threat detection, which looks at kind of patterns against your database. So it can see patterns based on a bunch of machine learning algorithms that we've used or built and used and trained against all of these databases to look for things like, hey, this is a user who shouldn't be signing into your service or who doesn't very frequently sign into your service and is now downloading the employee's database. And so that can alert you automatically, fire off an email for you to perform an action, whether that's cut the user off or, oh, no, this is a known thing. This is actually an employee who's doing some investigation, right? So you can have all this kind of automation built into the system. And it's there for you. Finally, these are cloud services. I mean, it's, your ability to go light one of these up takes about 3 minutes. You're able to scale to, if you happen to be a small company, you can scale to what a Fortune 100 company can do, on day one. And because it's based on kind of familiar SQL technologies, then all the skills that you already have transfer very, very quickly. So you can get up and running very quick. So I'm going to actually walk you through a demo. It's a little easier to show you stuff than it is to just talk about it. So we're going to flip over to my machine, which is waking itself up here. We're going to log in it a little differently. And what I'm going to show you is this kind of concept of how we would take data coming into the system. So if you think about the Xbox case as all this telemetry data coming in. And I'm going to walk you through a little bit of kind of the depths of how this works. So I'm going to show you kind of step by step. But realize that most of what I'm about to show you is actually automated. So things like Azure Data Factory runs this process called Polybase for us under the cover. So it's going to do everything that I'm going to do in just a simple pipeline. So moving data from Hive export all the way through to SQL Data Warehouse. But I want to explain this process so you can kind of get a sense of what the power of these systems are. So the first thing I'm going to start with is this concept of an MPP system. Since I didn't get a lot of hands for who knows what an MPP system is, I'll explain what this is. So imagine there's about, 35, 40 people in the room. Imagine we're going to build a wall. So sitting here on the floor, we have a pile of wood, we have a hammer and some nails. And we're going to build a wall. So in an SMP system, or a symmetrical system, what we're going to do is we're going to start with a single hammer. And so I'll come up, I'll hold up the first board and the second board, and I'll take one nail and I'll hammer it, and I'll give it to the next person. We'll walk around the room like this. This is how an SMP system works, right? So you think of a single core. Now we would move to multi-core, so maybe we've got a couple of hammers in the room, but we're still sharing a bunch of stuff. So we're sharing a single pile of wood, maybe a single pile of nails, and so we're kind of fighting for this. Oh, no, I want to get that nail. No, sorry, you got that nail. So you have this context problem. So the resources are being contended with constantly. In an MPP system, it's a divide and conquer methodology. So the concept is that you share nothing. And so there's a control kind of system over the top, or think of like a traffic cop. And essentially, if we're going to do that again, imagine we all have to hammer a single board with a single nail. Well, imagine instead of one pile sitting in front, each one of you has your own pile of wood, your own pile of nails, and your own hammer. And there's one person in the room who goes, all right, you ready? 1, 2, 3, go. Boom, we're all done. That's how an MPP system works. So when we take a system like this, what we've done is we've taken SQL Server and we've distributed it. So in this case, it's built across 60 distributions. And when you run a query or ingest data or select data or do anything like that, you actually have this parallelism that's happening. And so that's the compute you can control. So essentially, using my wall analogy, how many in the people in the room have hammers and nails? So you could have 1, you could have 60, and you can scale that up and down as you see fit. So the more operational processing you need, the more compute power you need, you just scale the system up. So that's how this works. Now that you have that concept, it seems like, okay, well, that's something I have to think about. In the case of SQL DW, you don't. So this is standard T-SQL code. I'm not doing anything fancy here. You can see I'm creating a set of schemas. You can see I have this concept of just a dimension date time table. But there's a couple things I want to point out. Now, if you notice at the bottom, there's a couple of key pieces. One is the data, the distribution model of the data. So how does the data lay across the room? So we go back to the hammers and nails analogy. How do we put the hammers and nails efficiently throughout the room? Because we have, say, 60 pieces of data. We want to make sure that each one of the compute components has the right amount of data to process. So you get control of how the data lays down. In this case, I'm using a round robin table, which is exactly like it sounds like. It sounds like one of those old typewriters, right? First row goes to the first node, second row goes to the second node, third row goes to the third node, and it goes all the way to the end, ding, goes to the first row and keeps working, right? And so it's just literally distributing the table across. You'll also see a hash distributed model where essentially you're trying to put data that's kind of together or very similar together so that it can be all processed together. In these systems, the Achilles heels of all distributed systems is moving data. So you can imagine, I have 5 petabytes of data. You ever try to copy like a terabyte file from one drive to another drive on your machine? Like you just watch the Windows thing come up and go copying, you now have calculated 17 hours, right? Imagine a petabyte of data. So you want to optimize around data movement. So you get some control of how this data lays down for performance. And so you can see this here. Now I'm actually just going to run a query out of that table. Pretty straightforward. And in just the split second it took me to run that, what happened was I sent a query to the cluster. The cluster said, okay, I've got this query. I'm going to create a distributed plan, sent it to 60 nodes. They ran their queries individually, those small parts of work they had to do. They came back to the head node. It was aggregated, and then sent back to me sitting here on SSMS. So it all happened in a split second. So it actually did all of that work in front of you. And it was just simple select star. So pretty straightforward query. But it gives you the idea of the power of a system like this. I don't have to learn a new skill. I didn't really have to think about an MPP system. I get all that scale out compute. I also have a fact table here. So this is about 100 million rows. It's just a sample set, so it's pretty small. But it's really here just to give you some kind of example of how you could use a system like this. We see commonly tables with billions of rows. I've seen somewhat infrequently tables with trillions of rows in a table. So this is what this kind of system is for. I've got all of this data ingested, and I want to make sense of it. So I want to reason over it. So we're going to go take and do kind of a simple aggregation. Now this is kind of a building of a story arc, which is, hey, I want to go and learn a little bit about how people are getting stuck inside of, say, Xbox, maybe in the console. We introduced a new video feature, for example, and maybe it's 5 menu clicks down. And so what this is going to show you is basically steps or click points within the UI and how long it takes people to get there. So I started my console up, and maybe it took me 5 minutes to find that new video thing. Or maybe it took me 10 hours to find that thing. Or maybe I didn't even know it was there and I've never found it. So what we're looking for is how many times people actually clicked on the thing that we're looking for, and how long it took to find it. So how long did it take them to get there from the time that they started. So you'll see the visit duration is how long from the time the console started till they find that event. And you can see this is a pretty simple kind of aggregation. And what it's going to do is it's going to go run an aggregation. It's going to say, here's the step. You can see they're really fancily named here, step 1, step 2. So this is some location in the UI. How many times people actually clicked on that, and then how long it took them to find it. So this is a sum. So it's showing me how much time in aggregate it took people to find particular features. We're going to focus on step number 4 here, which is rather interesting, right? It's a step that took people forever to find. Maybe this is the new feature we just introduced, but it wasn't clicked on very often. So it's like, well, maybe I want to do a little more insight into that. Is this something I care about? So we're going to weight the average of how much time they took. So I'm going to simply run another query on it. And you can see, now again, this is 100 million rows, so it's not a lot of data. I can do it pretty fast. But you can imagine that this was 100 terabytes of data, and these kinds of queries will take minutes. And so something that potentially would take hours or days, or sometimes not even complete in an S&P system, will take minutes in a system like this. So I can go ahead and run that query again, and I can get the aggregate data. Now for step 4, we've noticed that that's moved up. And so we're looking at, hey, it's really hard for people to find this feature. It takes them very long amount of time on average. It's the most latent part of the system. So maybe this is the feature we just introduced. We're super excited about it. We think customers are going to get a lot of value out of it. They can't find it. So from a user's experience perspective, we can then start to go do some things. We can start to make some decisions. Now again, this is a very simplistic case, and it's just giving you an idea of the power of the system. Now we're gonna pivot here to one last kind of component. Now we've been talking about 100 million rows, and this is kind of a small set of data. And we've been talking about kind of this loading pipeline of how we move data in it. I'm going to introduce a technology to you if you haven't heard it. Who's heard of Polybase before? Okay, quite a few actually. So for those that don't know, what Polybase is it's a technology built into SQL that allows you to go out and query non-SQL assets. So imagine you have something like HD Inside or Hadoop sitting over here on the side, or you have blob storage there. You can actually run a query from SQL that has SQL Server go out, reach into those environments, grab data, aggregate it, and pull it back into SQL, and be able to use just like you would any other table. The concept is these systems are kind of prone to having all kinds of data in all kinds of places. Used to be 10 years ago, we would talk about, hey, you got to move all of your data into SQL, right? Here's SSIS, and here's Informatica, and all these tools to move your data into one place. And now what we're seeing in the world is that the distribution of data is kind of mastered, because as soon as we start having to move data around, you start encountering problems. And so taking the query to where the data is really important. In the case of something like HD Inside, if you look at SQL Server 16 or SQL Server 2017, it has the capability of pushing that query down into Hadoop and making a decision based on any kind of query cardinality statistics that it wants. So if you think about the query engine in SQL, it will actually take all the statistics about the data in that external system and make a decision. Say it's Hadoop, it's connecting to, say, Hortonworks. and it realizes, hey, there's a lot of data there. The most efficient thing for me to do is generate a MapReduce or yarn job, push it out to Hadoop, let the Hadoop cluster execute it, return the aggregated results, and push that back in. It's all done automatically. You're not doing any of this control. So I'm actually going to walk you through how you would do that so you can actually see this running. The first thing we're going to do is create a credential. And this is the credential of where I want to connect to. The next thing we're going to do is create a data source. This is actually where my data lives. This is just a sample, and I'll show you how this all works. And I'm just telling it, here's the blob container and what location it is in storage, and then how to connect to it using that credential I just supplied. And the next thing I'm going to do is create a format. So what format is the file in? In this case, I made it really simple. It's a comma delimited file, so I can actually show you in an editor that this is real data. But this could be something like an org file coming out of Hortonworks or Hadoop. It could be an RC file. It could be a lot of different formats. And so they can also be compressed. And so we have different kind of compression formats. So you're able to kind of use the formats from these other systems within SQL. In this case, I made it really, really simple. And then we're going to go through the concept of creating an external table. And so in this case, I'm defining the table like I would any other way. I'm going to give it the location. So this is the specific location within that container of where I want to get the data. In this case, it happens to be a single file, but it could be a directory structure. And we can parse the entire structure. So we could walk a tree, for example. Obviously where the physical sources of it, and then the format. So it's as simple as creating a table like that. Now, I'm going to now load that data. So again, everything I'm showing you, this is what an ADF pipeline is doing under the covers on your behalf. So you don't have to go hand code all of this, but this is kind of what happens. So now I'm going to introduce a second statement, which is what we call a CTAS, or create table as statement. And essentially what happens is it takes the ability of that data to be able to go from one table to another, but it does it in a parallel fashion. So imagine we have all of these nodes running. You want to make sure that each one of them is efficient. So we're not doing a row-by-row operation. In this case, I'm going to pull all of that data from that external table, and I pull it into this instance. Now, this is what the file looks like. It's just 10,000 rows of just random text here, and you can see it's just a comma delimited file. It's sitting up in my blob storage account, so it's pretty straightforward. But as I do this, what's happening now is the system has reached out to that file, and since blob storage is built on a block model, it's actually reading it in parallel. All of the nodes are reading the blocks in parallel, and they're now ingesting that in parallel. So you can see 10,000 rows is pretty fast. I do another demo where we do it about 1 million rows. It takes about a minute. So it's very, very efficient to be able to do this in parallel, move all of that data into the system. In this case, I put it into a stage table. And you can see I did some operations on the data to get it into a format that I wanted. And in this case, finally, I'm going to do an insert select. And I'm going to take data from that stage table, assume that some step in here in between, I maybe massaged it or aggregated or cleaned it up or did some data management over the top of it. And now I'm going to put it into my final table, in this case, my production table. So in this case, it's a simple insert select. And again, this is all happening in parallel. So we just took those 10,000 rows from one table and moved it to another. Another common pattern is to land data in a stage table, pre-process it, and partition switch. When you start talking about things in billions and trillions of rows, that's a lot more efficient than moving data through insert selects. But essentially, it's the same concept. So now if I go back to my big table, you can see I now have those 100,000 rows added. And I can start to do my aggregations again. So if I want to see that same thing, you can see instantaneously I have access to that data. And I'm going to run that aggregation again. And in this case, step number 4 is still our top problem. So we now have a couple more people who hit it, but we don't have any more access to what they're doing with that data. So you can see very quickly, now again, this is just a somewhat contrived demo, but very quickly you can see you can take the skills that you already have with SQL, you can ingest all this data, you can land it, and you can start to aggregate it and build from there. Now the last piece of this puzzle is how you scale this service from here. So SQL Data Warehouse has kind of a model built around these latency queries. So if you're familiar with SQL Server, you imagine thousands or hundreds of thousands of people hitting a single box all at the same time for the back end of an order system. Hey, I'm ordering whatever widgets off my website. I'm inserting those orders into the system. SQL Data Warehouse is not a system like that. It's built for taking these massive amounts of data and aggregating it for presentation. So whether that's in analytics models or whether that's for machine learning or whatever, you want to be able to take all that data and get through it very quickly. So it's a big compute engine. But it doesn't deal with concurrency very well. So it's not going to be a system that you put on as the backing store behind like Office 365 Analytics as the front end system. And so the way we scale that out is we use a secondary service called Azure Analysis Service. And that's what Josh is going to walk you through. So we're going to pivot here, and we're going to take, now I've aggregated all my data into a way that I can make sense of it. Now Josh is going to show you how you take that data and actually scale it out to end users, what the kind of the next phase of the product is here.
Good. Thanks, Matt. So how many people have actually used analysis services before? 1, 2? All right. Before I talk about what it is, do a quick quiz. Okay. Lose the mic? There we go. I want to show a couple BI products, a couple reporting tools, and just raise your hand if you use these or know what they are. How about that one? All right, that's Power BI. Tableau. Last one's a little obscure, though. Anyone use Excel? Ever heard of it? All these can go ahead and access Azure Analysis Services. What Azure Analysis Services is, it's a platform that we actually built on top of SQL Server Analysis Services. It's shipped with SQL for almost 2 decades now. And now we've moved it to Azure as a platform as a service. What it does is it actually will let your business users, your non-technical users, people who may not know how to do SQL, it lets them get to the data that you have and all the sources that you see here on the left and a bunch more. And it lets them get to it in a way that's more friendly to them, in a way that's very quick for them, and lets them build out their own reports. So how does it do that? One is it provides this semantic model. The semantic model is kind of the lens that your business user looks through. And it kind of takes all those tables that you have stored away in staging tables and in data warehouses and turns it into something that's a little bit more business friendly without you actually having to physically change those tables in that database. So for example, this is Power BI. This is me connecting directly to SQL Data Warehouse. And imagine you're a business user, an analyst. You really know that data well, but you don't necessarily know the database, how everything is stored. So when you connect, you get a list of tables. You can kind of go through those tables and try to find the ones you need. Power BI has some good UI here that gives you a little preview of the table. But it's still up to that user to decide what data they're actually looking for and which tables represent that data. Once they find their tables, they have a bunch of tables now. It's up to them to figure out how those tables are related. What do you join on? Sometimes it's easy to figure out. A lot of times it's not. And then there's the business logic. What is week-to-date or weekly revenue? How many people work in a place where the definition of a week for reporting is different than the calendar definition? Things like that is something that a user would have to figure out on their own when they want to build a report. This also means a lot of times they walk into a room trying to present the same data with the same names on the metrics, but they actually show different numbers because they all came to a different conclusion of how to calculate that number. So the semantic model lets you encapsulate all this information in there. This is one of the diagrams of one of them that I've built. And basically you can see all the relationships between the tables are in there. The tables themselves have friendly names. You can put descriptions on there. You can put all your calculations in there. You can also put your security in there. So we have row level security, meaning if I can only see the US, I can look at a report and all I see is data for the US. Someone else can look at that report and see data for Canada or some other place. All that is enforced here, even if the underlying data store doesn't enforce that. That means then you can take all the tools I showed and a bunch more and just kind of connect to that analysis services model and just start going. You get a blank canvas to work with, but you also get all the tools in your tool set, all the metrics, all the fields, all the dimensions. You can go and just start dragging and dropping and pulling stuff in. The other thing that analysis services lets you do is it can give you really, really fast queries. It provides a caching layer that's fully in memory. It's column-oriented. You pick your data. You load it into that cache. And now when your users come in and query it, they all hit that cache. That takes a lot of load off your underlying database. You can even turn your underlying database off if you want. And it will give the users a very fast response time. And that's important because all those tools I showed you are actually pretty demanding. This is a Power BI report I built. Each one of these visuals on there, this one has 4, generates their own query every time you click on something on that report. Every time you drag something on there, it's firing off queries. So immediately when someone opens this, it fires 4 queries off. They will hit the cache rather than hitting the underlying database as long as I have that cache turned on. And they will return in under a second generally. So let's take a look real quick. How many people saw the keynote? I think it was the first day. This report was in there. This is a report in Power BI. It's connected to Azure Data Services. And it's showing telemetry data from a web application, basically the average response times, the number of requests, and the different shades of the colors of the average response times of those requests. And there's a couple billion rows in this data set. And down here you can see all the requests over time. And I can actually kind of go in and highlight a specific period. And then it'll fire off those queries against that cache as soon as it refreshes my access token. Yeah, man, there we go. And it'll scan and just give me that range. I can drill in even more. And I can basically do analysis over this report to see really to highlight where high latency is happening and try to troubleshoot those problems. Now, you may have seen reports like this in other tools and other systems. Usually, though, when you're talking about this volume of data, those are built by some sort of developer. And usually the database behind it is either optimized for it or you've written stored procedures to make sure that you're running the best query possible. This report here can be built by basically anyone, any kind of business user, any kind of analyst. They don't need to have that technical skill. They can go connect to that analysis services model and drag and drop, and you really use any combination and get the kind of perf that I was showing there on that large data set. So let's go try this real quick. When you connect fresh, now this is what you'll get. You don't get just a list of tables, but you get the tables represented in a way you can understand, and you get the metrics already baked into here. So we were looking at the number of GET requests. So I just grabbed number of GET requests. I can drag that on here. And again, so when I pulled that on there, it went from my machine up to Azure, scanned the entire request table, or whatever I call that table, transactions table, and went over billions of rows and returned just in that time as I pulled that on there. So we're looking at number of GET requests by time. There's a time hierarchy I can go and just pull in here. Boom, again, did the same thing, ran the queries. You can see why these are very demanding because they're running lots of queries every time you're dragging. Let me sort this the proper way. So now you start to see we're building out the same report that we had on the other screen. I can come in here and I can plot all the requests by the response time. On a map, if I want, I can take the latitude and longitude. Again, every time I'm clicking, this is firing off queries. And let's look at the response time. Boom, plotted, scanned all those rows. And let's do one more. We're starting to build out the same report we had here. Let's look at the, what's the fastest operating system out there for at least this application? Let's look at the number of requests. And we'll slice it by the OS. Oh, there you go. So we built out the report. We just dragged and dropped. Didn't have to know SQL. I didn't even have to know where this data is actually being stored. And it's very quick, even with the large volume. And I could have dragged any combination on here. In addition to that, automatically, all these visuals are linked together. So when I click on one, it filters down the other. Power BI is able to figure that out because that semantic model behind the scenes tells it what's related to what through the metadata. So how do we go ahead? Actually, before I do that, let me show you this. So that's a little application. This is actually a real model that is built by the Skype team. They use this to measure or to monitor call quality and their metrics for interactions on Skype. And you can see this is a much richer model. This is real. This is what they look at. And this is something that a business user can come into. Let's go down to metrics. They have lots of metrics in here that someone would have to know how to calculate on their own if they were doing this themselves. Oops, zoom in a little bit. So all this business logic is kind of baked in here. And that means anyone can come in and start building these advanced reports without really having to know what's behind the scenes here. Let me flip over to our designer view. This is our Visual Studio tool, SQL Server data tools. This is that same model, but from the designer side. And just here's one of those metrics, just to kind of give the point. This is audio. This is good call quality. And to calculate that, you have to apply all these different filters. And this is something that the subject matter expert knows. They bake into this model. Now, anybody who builds a report that includes this metric will always have the same number. because that logic's already kind of built in for them. So how do we go ahead and build one of these? First, you can start in Visual Studio. And if you go to Tools, Extensions and Updates, and you search online for Analysis Services, if you're in 2017, you will see us come up there, and you can install our project templates right from here. If you're on an older version of Visual Studio, you can just search for Analysis Services, SSCT, or SQL Server Data Tools for whatever version you're looking at, and it'll usually come up on the top of the list. And this will work on any version of 2017, the one I have now, including the free community version. So once you've installed this, you have access to our project templates. You can come into Visual Studio and say you want to create a new project. And the one you would select under Business Intelligence, you'd select Azure Analysis Services Tabular Project. You can name it. We'll connect to the same database Matt was using. So, OK, that's just the name of the project. And what this window is showing you here is they basically want you to have a pick your workspace. So what we do is we actually let you interact with the data as you're building out the model. So we need a place to kind of put that data. We have a new feature here called Integrated Workspace. And what Integrated Workspace does is we actually have in Visual Studio the same engine code for Analysis Services running right there on your machine. So you have all the same functionality, but it's local to your machine. So you can actually import data, start building your model, do everything I'm going to show here without actually having to buy a server in Analysis Services. And this is, again, with any of the additions of Visual Studio, including the free one. It'll just do everything locally at this point. So I'll take that, say OK, and I'll basically just set up my project. So I have a blank project now. We need to get some data. Luckily, Matt prepared some for us in Data Warehouse. You can right-click on Data Sources and click Import. Bunch of different connectors on here. If you're familiar with Power BI, this will look very familiar to you. If you've used Analysis Services in the past, this looks nothing like what we used to have in there. We've actually adopted the same connectivity stack as Power BI, so we can do all the same connectors and transformations that they do. Also known as the Power Query connectors. So in this case, do Azure. Let's do SQL Data Warehouse. Connect. Go to my cheat sheet. Grab our server name. Again, this is something that the modeler would do. This is the more technical person who's going to build the model out for the non-technical person to go in and build out their own reports. Say OK. Matt insists on having security, so I have to log in. Connect. And now I get to pick my database. And now I get a list of tables that I can choose which ones I want to include in my model. So this is a small database, not as complex, but it's a good one to start on. So I'll pick date, I'll pick products, I'll pick steps. These are the steps of the different screens where people are stepping from one to the other. And we'll take the transactions fact table. Is that the right one? There's only one row. Maybe, I had a cached. Wow, we cached between sessions, that's new. Anyway, so you can kind of see a preview of all the data that's in there. Now the fact table here is 100 million rows in there, and since I'm doing this all locally, I probably don't want to download 100 million rows. So as I'm going to hit OK here, before we actually go and download all this data, you have a chance to edit and transform those queries. Again, if you use Power BI, this will look familiar to you. We could spend a whole session on just what you can do. We could spend several sessions on just what you can do in this screen alone. But I'm just going to use this screen right now to filter down my rows so I don't have everything. So I'm going to say, keep top rows and give me the first 1,000. And let's go ahead and import. What this is going to do is going to generate all the queries for you to go pull this data in. If you had done some more complex transformations in here, it would have also generated those queries to do those transformations on the source database. A lot of people know SQL really well, but if you don't know Hive, you don't know how to query from Blob Store or any file formats, that UI there and the query language behind it called M will actually abstract all that from you and generate the queries for you. So this will take a couple seconds. So this is very new. We just released it in Azure Analysis Services 1 or 2 weeks ago at this point. But there we go. We went and transferred all the data in. Steps table at 24,000 rows. And I filtered that transactions table to only give me 1,000 rows. So, okay. And now you can see all that data, which really helps you kind of build out the model, build out your calculations. Let me flip it over to our diagram view. So we don't have relationships in here. So again, I know the data. I know the relationships. So I'm going to put them in here so someone who doesn't know the relationships can take advantage of this metadata. So I'll go ahead and I'll say date key. I'll drag and create that relationship. Product key. What did you name the product key? All right, we'll skip product for now. It was product yesterday. We have steps. So steps actually, there's a to step and a from step. It's the same dimension. Now if I was in SQL, I'd have to write 2 different joins to get the data, maybe in the same query. For user, I can actually go ahead and name this. Let's say I'll name this from steps. And I'll join it to from steps. Now I can actually go in here and I can create a calculated table that I'll call to steps. And it is the exact same as from steps. Let's rename it. I'll come back and I'll join it to 2 steps. And what this means is that a user, when they come into the UI, they'll see both from steps and 2 steps, and they can choose the one they wanted to use for their query. It makes that a bunch easier for them. So you can see I can come in here, I can start renaming these things, making them a little bit more friendly. I'll just call that date. Transactions. I can do this to the columns as well. You can put description text on here. You can hide things that aren't relevant to the user. You can flat out delete them if you want to. And I can start to bake in some business logic here. Again, this is not the most complicated of models, but let's say I just wanted to have the number of transactions in here. So I can go ahead and say number of transactions equals, let's just say it's a count rows of the transactions table. Now I have that in there. Now again, all of Analysis Services is actually running here locally on my machine. So I can actually go and connect Power BI or Excel to that, and we can see what the work we've done already. Say OK. So go and open up Excel, and it'll connect it to that process that's running inside Visual Studio right now, rather than connecting to it up to the cloud. And you can see there's the transaction table, there's the date table. Collapse this a little. There's our from step. Products, we have 2 steps. So I can start to take these and just start querying them. And you can kind of see it as you're building your model out here. And you get a preview of what your users will see when you actually go ahead and deploy this. So let's actually go ahead and deploy this. Done with Visual Studio. I created a server up in Azure before. If you need a server, you go to the Azure portal, click on New. Under Database, Intelligence and Analytics, you'll see Azure Analysis Services. In a couple clicks, we'll create that for you. Oops. If you go over to your Solution Explorer and right-click on the project and do Properties, you will see a deployment server. Right now, it's pointing to my desktop for some reason. We'll change that to point to my Azure Analysis Services server up in Azure. I can choose to name that database or model whatever I want. I'll say OK, and I'll say deploy. Nope, I will say deploy. There we go. By default, we go ahead and deploy the metadata up there, but we also go ahead and we actually go ahead and process it right away. If you don't want to process your data, there's another option in that settings menu I was showing to say don't process, and you can process it again manually. Processing will just take that data from DW, maybe aggregate it, do whatever you told it to do, and put it into the cache. So this should take another second. 2 seconds. Any second. There we go. So it's deployed the metadata, and it's processed the rows. Now, we put a filter on there because we didn't want to take in the whole transactions table, which was good when we were on our local machine, and we just needed a few rows to develop. But when you want people to get the right numbers, you probably want to have all the data in there. So I can actually go over. You could do this before you deploy. I typically see people usually do this after, and it's usually automated. I'll flip over to SSMS. And in SSMS, I'm already connected to that server. Let me refresh it. I have the DW down here that we just connected to, but here's the Analysis Services server. And we see our Xbox build database here. And when I right-click here, I'll look at tables, and we see the transaction table. And I can click on partitions. Now, you can partition your data. And what this will let you do is a few things. One is to let you incrementally load your data. So as new data comes in, you can add a new partition and process that data in for that partition or that day, whatever you set that partition to. And when you have multiple partitions, you can reprocess them in parallel. So you can actually fire off multiple queries at one time, which can make the ingest a little bit faster. So right now we have a partition, and that partition has a query. And that query is filtering for the first 1,000 days. So what I could do, first 1,000 rows. So what I could do here is I could change this query to be for a day, and then I could copy it and create one for another day, and another day, and another day, so I have partitions for every day. I could do it manually here. I could do it programmatically, or I could do it through scripting. So here I have a script I've written that basically alters that table, and it will essentially create a partition for 510, where the date is equal to, the date key is equal to this, which is 510. Another one for 59, and so forth. I can keep creating multiple partitions. Typically what someone will do is they will automate this. They'll use one of our client libraries I'll show you in a moment to go ahead and at runtime, they'll go do their ETL into DW. They'll create new partitions there. Then they'll figure out what day it was inserted. They'll go insert that, create that partition in Analysis Services, and then go process that partition in Analysis Services. They'll do it all programmatically. We saw SSDT. This is just another version of the slide Matt showed, where the typical, you'll capture your data, you'll ingest it, you'll maybe move it from blob store into HD Insight to do some to sanitize it, then put it into data warehouse where you start doing querying on it, and then you'll build Analysis Services as a cache on top of that, so that lots of users can go and connect to that data and build out their own reports. One nice thing about making the data easier is more people can use it. That means you get more people using it. That's where that cache really comes in handy to help protect your assets below it. We have a lot of different coding options that will let you programmatically query the data, programmatically manage the models, and create the models. On the right is all of our different libraries. So MSOLAP is our native provider for querying. ADOMD is our managed provider. AMO/TOM, TOM stands for Tabular Object Model. That's our .NET client library that essentially everything you saw me doing in Visual Studio is going through that library. So you can do that all yourself programmatically. That'll let you create partitions, process, or dynamically create the entire model if you want to. TMSL is the Tabular Model Scripting Language. That's what I was showing you in SSMS, where I was creating the partitions. And then since this is an Azure service, you can always, always use PowerShell or ARM to automate. This is just a little bit of a shot of what Tom has in it. So you can see the server, the database, the model, the different data sources, the tables. Everything that you can do in Analysis Services can be automated through Tom. And here's just an example of me. This is an Azure function that I wrote that actually, basically when triggered, will go and it will refresh the cache in that model. Essentially here I'm connecting to the database. I had a Twitter one. And what I'll do is I'll just call on that database, on that model, I'll request a refresh, which will reprocess that entire cache. This is doing the entire model. You can do it partition by partition or table by table. But all this can be done programmatically. There's a white paper here if you get the slides. Automated partition management with Azure Analysis Services. There's a long white paper that tells you how to do all different types of processing. If you want to do rolling windows where you add new days as they come in, but you drop old days. It'll show you how to do that. And it'll also give you the code samples that'll let you do that, and it'll show you how to build this Azure function out, a more complicated version of this if you like. So that's what I had. There's a few links on the slides for learning more. All these services are live now. Azure Analysis Services went GA about 3 weeks ago. And we have our Azure blog, where we're posting the partition management and other things as well as new features roll out. There's a lot of cool stuff on just the new features that have come out with Analysis Services recently. At this point, any questions?
Yeah, so as we wrap up, the thing we wanted to illustrate to you is, you imagine that there's these data solutions, right? And in the past, this has been really complicated. It's, hey, conversations would have sounded like, okay, how much data do you have? What are your SLAs? Okay, let's start talking about cores and spindle speeds and all kinds of stuff like this, right? And you can see very quickly we were able to take a set of data, ingest it into the system just using simple scripts, be able to build models and actually surface that to you just through clicking. And much of what we showed you is actually the depths of what you would have to do. Much of this, things like the polybase import that I showed you, you can actually just go into ADF and create a pipeline by clicking some buttons. So much of what we've shown you is very, very simple to set up. And it gives you the ability to take what you have, take the data you already have, add additional data as it comes into your system, whether that's new data, whether that's partner data, whether that's data that you didn't think you could use, pull that into the system and start getting insight out of it very, very rapidly. And then expose it to your business users in a way that sounds like English. Hey, how many people hit my service from this operating system? That's an easy way to talk to somebody who doesn't understand, say, SQL. Oh, well, I got to go to the fact something table with this dimension. Like, you've lost people. So being able to expose this data to ways where your business can actually take advantage of it very, very rapidly is what these services are built on. So with that, it's the end of build here, I guess, on a Friday afternoon. We appreciate you coming to our session here at the end of the day. We know it's a long day, but we do appreciate the time you spent with us. If there's any questions, well, Josh and I will stay here a little bit after. We'll ask or answer any questions you have. Thank you for your time. Thank you for coming to Build.
Thanks.